Hello, my name is Tayson from casaGeo, the data science and location intelligence company. In the last video I showed how to connect Alteryx to a postgreSQL database and how to load geometries from the database. Unfortunately, this doesn't always work. Here is a simple example. We run the workflow from the last video again. Now I click on Table or Query in the Input tool and then select the SQL editor. I change the select statement and add the line limit 100, so that only the first 100 records are selected. The test says that the statement is OK. So I press OK and let the workflow run. Oops, instead of a geometry it only shows me an alphanumeric chain. Sure, I could have entered the limit directly in Alteryx, but there are questions where it makes sense to work with the select editor. And there are database connections where the transfer of geometries generally does not work. For example, if the database connection to postgreSQL is set up centrally via the Alteryx server. It would be stupid, of course, if the geometries were to be shot to pieces as soon as you start working with the SQL editor. We remember that in the last video I had installed the extension PostGIS for postgreSQL. We now need the PostGIS command st as GeoJSON to convert the geometry. For this we call the SQL editor again and change our syntax. We then call the expression geom again. We see that the variable is now a GeoJSON but still no geometry. I add the select tool. The variable geom is a VW string with the length of 8190 characters. I will come back to the length in a moment. Now I change the type from VW string to spatial object. I run the workflow and see that not all geometries are created. If we convert the geometries to GeoJSON, the expressions can get very long. But the ODBC driver only allows a length of 8190 characters. If the expression is longer, it is truncated. The string is incomplete and Alteryx can no longer create geometry from it. To stop this from happening, we need to edit our PG Alteryx connector via the ODBC admin. I click on Configure and then on Data Source. In the max long varchar field it says 8190. The value was also in the Select tool earlier. We take 100,000 instead. Now we run the workflow again. All geometries are displayed, and the Select tool shows the value 100,000. Important: if the problem occurs when reading in data, it also occurs when writing to the database. Here you have to proceed in the reverse order. First convert the geometry into a string in Alteryx and then convert it back into geometry in the database. I will show you exactly how it works. First we rename the variable geom to GeoJSON in the Select tool. Then we convert the Browse tool into an output tool by right-clicking on it. Select the database Alteryx and create a new table, which we call testplz5100. In the next step, I edit postgreSQL statement. I add the geometry column with the statement add geometry column. Test for the schema in which the table is located. PLZ5100 for the table name. Geom for the geometry column. 4326 for the projection. This is the WGS84 projection used by Alteryx by default. Multi-polygon for the geometry type. And 2 for the spatial dimension. Of course you only have to do that when you create a new table. Now I just have to update the geometry column, for which I use the update command with the stgeom from GeoJSON function. We look at the result in the PostgreSQL database. And it worked. Great! And that's it for today. If you liked the video, give us a like, and if you are interested in the topics of data science and location intelligence, then subscribe to our channel. Thank you very much for your time.